Hi, I'm JD, and today what we're going to be doing is linear equations with fractions, everyone's favorite. So if you would, let me get out of the way, try to do these on your own. The first problem is 1/3 x plus 5 equals 1/2. Second is a negative 3/5 x plus 1 1/4 equals 2. And then the third equation is 6/5 x. That's a plus 4/3 equals 3/2. So try these on your own. Pause the video. All right, hopefully you work these out and try these on your own. Now, another way that you can kind of check yourself, especially when you're solving for x, is just plug it into the original. If both sides are true, then it's a solution. If it's false, that means you did something wrong. And what would be a true statement? 1/2 equals 1/2. What would be a false statement? Well, 2 equals 3, or 1/2 equals 2/3, or something like that, where it's not equal to each other. But what you want to do in these problems is first multiply both sides by the LCD. If you look at the denominators have nothing in common. So that means your LCD would be 3 times 2. Now you can always do that. It won't be the LCD, but it'll still be a common denominator. So just multiply everything by 6, because that's your LCD. Now, when you do that, things are going to start canceling out. Well, yeah, things are going to start canceling out. This is 6 over 1, 6 over 1, 6 over 1. So you can cross cancel. 3 goes into 3 once. 3 goes into 6 twice. So that's going to be 2x plus, this is 6 over 1 times 5 over 1, so that gives you 30. 2 goes into both the 6 and the 2. 2 goes into 2 once. 2 goes into 6 3 times. So that would be a 3. Now it's just a simple linear equation. You subtract both sides by 30, right? Because you're trying to get this x by itself. And you want to remove the 30, so you do the opposite. So that's 2x equals, here's a negative 27. So you divide both sides by 2. And so x equals negative 27 over 2. That's your answer for this one. For this one, what you want to do first is change this mixed number to an improper fraction. It's always easier to deal with mixed numbers as improper fractions. So how do you change this to an improper fraction? Right, you take 1 times 4, which is 4, plus 1, which is 5. And you put that over 4, equals 2. Now what's the LCD here? Right, same thing. They have nothing in common, so you just simply multiply each term by 20. By 20 over 1. Alright, when you do that, you can do some cross canceling. And you're always going to be able to cross cancel. Let me rewrite this so it's easier to see. So you have 20 over 1 negative 3/5 x plus, and this is 20 over 1 times 5/4 equals 2 over 1 20 over 1 times 20 over 1. Now you can cross cancel. So the 5 cancels out with the 20, right? 5 goes into 5 once. 5 goes into 20 4 times. Then you just simply multiply across. So that's going to be negative 12 times x which is just negative 12x. You have 1 and 1, but 1 times 1 is 1, and it's in the denominator, so you can pretty much ignore it because it's implied. Same thing with this. The 4 cancels out with the 20, so you're left with 1 there, the 5 there. You multiply across. 5 times 5 is 25, and what's 1 times 1? 1. So it's 25 over 1. So that would just simplify it, just 25. So that's 25 equals, and then what's 2 times 20? Right, that's just 40. Now you got a simple linear equation. So you just solve for x. So you want to do the opposite, so you subtract both sides by 25. That cancels. You're left with negative 12x equals, on this side is 15. And then just simply divide both sides by 12. So you get x equals negative 15 over 12. But then you can simplify that. Both of them are divisible by 3. Right, so you divide the top and the bottom by 3. So you get negative 5 over 4. So that's how you do this problem. Now what I'm going to do now is I'm going to erase some of this work so that I can rewrite this. So hopefully you got this. If you didn't, you can always go back and rewind. That's kind of the beauty of this. So I'm going to rewrite it on the top so I have more room. 3 is 6 over 5 x plus 4/3 equals 3 halves. I'm also going to erase this. So the final answer was x equals negative 5 over 4. Now, in this case, you have 3 denominators. So the best way to find the LCD is just by comparing 2 at a time. If I have 3 and 5, the LCD of those is going to be what? Right, it's going to be 15. Then you have 15 and 2. What's the LCD of 15 and 2? How do I find the LCD? You can set up a Venn diagram. GCF goes in the middle. You have 15 and 2. What's the GCF 15 and 2? There is none. So it's just 1. Then you ask yourself, what times 1 will give me 15? 15, right? And then ask the same question here. What times 1 will give me 2? 2. And then just simply multiply across. What's 15 times 1 times 2? That's 30. And that's how you find the LCD. And then you just multiply each of these by 30. So you have 30 over 1 times 6 over 5x plus 30 over 1 times 4 over 3 equals equals 30 over 1 times 3 over 2. See that? So now you can just cross cancel. Right? You're just multiplying across, so now you can cross cancel. And you can cancel in the numerator denominator or by the diagonals. Here's just the diagonals. So 5 goes into 5 once, 5 goes into 30 6 times. 3 goes into 3 once, 3 goes into 30 10 times. Here, both of them are divisible by 2. So 2 goes into 2 once, and 2 goes into 30 15 times. So then you have, here it's just a cross, so 6 times 6 is 36, so that's 36x plus, what's 10 times 4? 40, equals, what's 15 times 3? 45. And then you subtract both sides by 40. You get 36, because that cancels out. You get 36x equals 5. Then you divide both sides by 36. So your final answer is going to be x equals 5 over 36. Now, if you really want to, you can plug it into the original, 5 over 36, see if it's true, and if it's true, it's a solution. Alright, and that's pretty much